Alright, I know these combustion analysis questions are fairly fresh and a little bit of a struggle for maybe some people, so we'll go over both of them from the review sheet. Just remember that there's a pattern that goes with all of them, and it's really just kind of a setup of three different things that we've done during this lab. You're going to be doing some stoichiometry, you're going to be doing some empirical formula, and then sometimes some molecular formula. But it's really just three processes that you're familiar with, it's just combining them into one question. So for this first one, we have 2.66 grams of a compound. That's the size of our sample, so that's what's going into our burning apparatus, as shown in this little picture. So there's our 2.66 gram sample. We heat it up, we burn it, and there's going to be plenty of oxygen coming in through this side right here, and so it's going to go through combustion reaction. And as it combusts, it's going to release H2O and carbon dioxide. Those are always the two products of combustion. And so it's going to release the water, and the water is going to get absorbed by this chamber, and the carbon dioxide will get absorbed in this chamber, and then the excess oxygen will come out this end. So what we could do then is we could calculate how much water and how much carbon dioxide was produced by this combustion. And so in the question it tells us that we produced 1.74 grams of carbon dioxide and 0.72 grams of water, both of which were found using these two capturing devices right there. And we can use those, the CO2 to find out how much carbon was in the sample, and the water to find out how much hydrogen was in the sample. And then the difference between the hydrogen and the carbon that's in the sample, and the size of the sample will tell us how much bromine was in there as well. And we can use that to figure out our empirical formula. So let's start off by using our carbon dioxide, 1.74 grams of it, to find out how much carbon we produced. So to do this, we'll set up some stoichiometry. First step is just to convert grams into moles. And then the second step is to see how many carbons there is in the carbon dioxide. So we're trying to figure out how many grams of carbon were produced. So if we look at 1 mole of carbon dioxide, so 1 CO2, there's 2 oxygens and 1 carbon. Since we're only concerned with the carbon, that means we're going to write on top 1 mole of carbon, because there's 1 mole of carbon for every 1 mole of carbon dioxide. And the last step is just to convert those moles of carbon into grams of carbon. And that shows us the original sample, that sample of our mystery compound at 0.4749 grams of carbon in it. Alright, now we've got to do a similar process to figure out how much hydrogen was in that initial sample. So we're going to use our 0.72 grams of water to figure out how much hydrogen there was. First step is just to grams to moles. And then the second step is going to be, again, to figure out how many hydrogens there were in that water sample, how many hydrogens came from the sample. So 1 mole of water again, 1 mole of H2O, and there is 2 hydrogens and 1 oxygen in H2O. We're not concerned with the oxygens, just the hydrogens. So for every 1 mole of H2O, there is 2 moles of H. It means it's H2O, so 2 moles of H. Cancel, cancel, and now we're going to convert that into grams. And that shows us our original sample at 0.08059 grams of hydrogen in it. So if we add those two together, the 0.4749 grams of carbon plus the 0.08059 grams of hydrogen, I left a 9 off right there, 0.08059 grams of hydrogen, we would see that those make up 0.5555 grams of the compound. So C and H, carbon and hydrogen, constitute for 0.5555 grams of the sample. But we see that the sample weighed 2.66 grams. So where did that extra mass come from that brings it from 0.5555 to 2.66? It has to come from that bromine right there. So we can see then, if we have 2.66 grams of sample, and we subtract that from 0.5555 grams of carbon and hydrogen, that means we had 2.105 grams of bromine in the sample. So right there, with those 3 pieces of information, we can now calculate our empirical formula. We know that the original sample, that mystery sample, had 0.4749 grams of carbon, 0.08059 grams of hydrogen, and 2.105 grams of bromine. So from this point forward, it switches to just a normal empirical formula calculation. We're going to start with our grams, convert it to moles, divide by the smallest, and get our ratio that way. So we write down our 3 known masses. We're going to go ahead and convert all 3 of those into moles. So that's a pretty straightforward conversion into moles. Just make sure that you use more than one sig fig from your periodic table. And we get 0.03954. moles of carbon. And we get 0.07996 moles of hydrogen, and 0.02634 of our third element, bromine. So now we divide by the smallest, and the smallest ends up being bromine when it comes to moles. So we're going to divide all of them by 0.02634. And that will then give us our ratio of carbon to hydrogen to bromine. And it turns out to be 1.5, 3, and 1. So since we've got that 1.5 there, obviously we can't leave it as 1.5. We've got to switch it to a number we can use. We can't just round it up. So we're going to have to multiply everything by 2. So if we multiply 1.5 by 2, that means it's 3. So C3. H, there's 3 there, multiply that by 2, so 6. And then Br was 1, multiply it by 2, so it's C3H6Br2. So by combusting that, absorbing the water and carbon dioxide, we have distinguished that the empirical formula for this particular compound is C3H6Br2.